Hello everyone, again. My name is Soodeh Moallemian, and today I'm going to present you something really nice, believe me. I don't know how many of you are familiar with PET imaging technique, but believe me, it's really invasive and it really depends on manual analysis and detection of carotids and everything. So here I want to present to you some alternative called image-derived input function or EDF, which is non-invasive, and it has been proved to work with UCB-H radio tracer, which is somehow all over the brain and can only be the carotid arteries, which are arteries going through the neck to the brain, uh, can be used for quantification of these radio tracer. So we are going to introduce you PET Pro pipeline, which is a pipeline designed for processing PET images from 0 to 100, and it's all automatic for the first time. What is PET Pro? It's an open source MATLAB toolbox. It will be available on Git soon, but it is available upon request at the moment. It is fully automatic. It is designed for UCB-H radio tracer processing from ECAT HR scanner, and it relies on already existing methods for partial volume correction and other kinetic modelings. And how does it work? Well, people who are going to use this pipeline are normally medical doctors, neurologists. So it should be easy to use. We designed the pipeline so that it works with bitified data, bitified PET and MRI data, of course. And to run it, you need PET PVC toolbox, Magia toolbox, and HMRI toolbox, which are already there on SPM, and you can use it. What you should do is just use the configuration file, fill it with the information that is based on your data acquisition, and just hit run. That's it. It has different modules, but today I'm going to present only the carotid detection and EDF extraction. So what does carotid detection do? It essentially divides the image into two time windows, injection and signal. From these two time windows, as you can see here, we will make the mean signal and injection maps. And from these maps, on these maps, we are going to apply some masking, inclusive and exclusive, to detect only the two carotids that are mainly in the middle of the brain and image. So here in blue, overlaid on the injection mean map, you can see the voxels that we search for the maximum value for the seed voxel that represents the seed value of the carotid. That's weird. Okay, can you see it now? Okay. And then from that seed voxel, I don't know if you can see it, we will detect the seeds and then expand it to the neighboring voxels. We know the diameter of the carotid, so we define this extension due to the diameter that is previously defined. And then we define the hot and cold carotids, and as you can see in this slide, we segment the carotids as the cold region, which I have shown it in green. And the next step is to calculate the correlation between the seed value and the cold carotid segmentation to have the input function totally automatic, totally reproducible, and reliable. Here you can see the input function and input function after correction for metabolites. And in the next slide, you can see how it is really close to what we can get from that of blood, which means that the method is so close to what we can get using the invasive version. Here I have also shown you the comparison between the area under the curves for input function from the plasma and image, and you can see that it's almost close to 1, even though I have only used the default mode of the pipeline and not the parameters of the scanner. So overall, the pipeline could successfully detect at least one carotid in all subjects. For subjects with problems, we still can get the coordinates from the medical doctor and then run the rest of the pipeline. And we only have a 10% overestimation using the default parameters. Still, we can use the scanner parameters to reduce this 10%. And the quantification of the UCB-H, which I didn't present here, was really similar with 1.06 by the rate of VT maps from the blood and image-derived. To conclude, I can say that PET Pro pipeline can provide a reliable and reproducible alternative to the manual or semi-automated methods for processing UCB-H from ECAD-HR+. And of course, it accelerates the PET processing and ensures reproducibility, as I mentioned. Thank you very much for your attention. And I'm on poster 3, if I'm right. Please come and ask me questions if you want.